all my geometry students. So today we're going to be talking about conditional statements. And a conditional statement is really an if-then statement. So an if-then statement, we sometimes will call it a conditional statement. Okay, and the if part of the statement is called the hypothesis. And so when we're writing an if-then, we consider the hypothesis to be true because we're making a statement. And it's the then part that we're trying to prove false. And the then part is the conclusion, okay? And when we're writing these, sometimes we use symbolic notation. So for the hypothesis, we like to use the variable P. And conclusion, we like to use the variable Q. And I'm going to show you where that comes into play in a few minutes. All right, so let's look at an example. If it's Saturday, then I will sleep until noon. So the hypothesis is it's Saturday. And the conclusion would be I will sleep until noon. Now, I hope you notice that the if and the then are actually not part of the hypothesis or the conclusion, okay? Now, if I wanted to, that's a statement I made. I just made a conditional statement. I don't know if it's necessarily true, but if it is Saturday, I'm trying to prove the conclusion is false. Well, what if I woke up at 10? Did I sleep till noon? So when I provide one counterexample or an example that proves a conjecture false, that's called a counterexample, then it will make the statement false. Okay, so all you need is one counterexample to prove a conjecture false. All right, so sometimes conditional statements can actually be rewritten to change their actual meanings. So here's an example. If two angles are congruent, then the two angles are vertical angles. Is this statement true or false? If it's false, provide a counterexample. Well, I'm going to tell you, I believe this is a false statement because I could actually draw angles like this and mark them congruent to each other. That's like if they're being bisected by an angle bisector, right? Those are not vertical angles, but they are congruent angles. So I'm going to say it's false, and that picture is my counterexample. But now I'm going to rewrite it. I rewrite it as, if two angles are vertical angles, then the angles are congruent. So what do you notice I did? So hopefully you're noticing that I flipped the hypothesis and the conclusion. And when you do that, you're taking the converse of the statement. So when we flip the P and the Q, we're getting the converse. All right, so let's look at a conditional statement. If you're 15, then you're a teenager. So you are 15 is P, the hypothesis, and then you are a teenager is Q, the conclusion. So if I want to write the converse, I'm going to say, if you are a teenager, then you are 15. All right, well, let's look at the conditional statement. You are 15. So if you are 15, and they're saying that is the true part. That's the hypothesis. Well, then yes, if you're 15, you are a teenager. So this is a true statement. But if you're a teenager, then you are 15. I changed the meaning of it, didn't I? You could be a teenager and not be 15. You could be 18. So 18 would be a counterexample. All right, so when you take the converse, sometimes a true statement becomes false. Or sometimes a false statement, like in that earlier example about the vertical angles, sometimes a false statement actually becomes true. Or they both remain the same. They could be both true or both false, okay? But here's some pay attention, important. When both the conditional statement and the converse are true, they can be written as one statement, and that is called a biconditional statement. All definitions can be written as biconditionals, all of them, okay? All right, so biconditional statement is a statement in which we combine the conditional and the converse, using the words if and only if. And mathematicians like symbols, so we don't have to write all that out because it's a lot. We can write IFF. And IFF means if and only if. All right, so consider the true conditional. Let's write the converse. So I gave you a conditional. I'm telling you it's true. If two angles have the same measure, then the angles are congruent. If I flip it around, here's my P, here's my Q. If two angles are congruent, I'm using symbols, then they have the same measure. All right, they're both true. So I want to write it as a biconditional. Now, you don't have to be exact here. You could flip it around, but I could say two angles. Let me switch to red. So two angles are congruent if and only if they have the same measure. So you can see I can combine them. Now, to be quite honest, remember I said if it was you could write it as a biconditional, then all definitions could be written as biconditional. Well, this is the definition of congruent angles. Okay, congruent angles have the same measure. All right, now I want you to try. If 3 points are collinear, then they lie on the same plane. First write the converse, then write the biconditional, and then, so press pause, try it, and then come back and check. All right, so you're back. So the converse would be if 3 points lie on the same line. So you want it to be grammatically right? Then they are collinear. So something like that. Biconditional, put it together. 3 points are collinear if and only if they lie on the same line. So the way we write a statement in geometry can actually change its meaning. And we always would love it if we could write a biconditional because that means that it wouldn't matter. All right, negation. So negating something in math or in general means to make it the opposite. It's like making it untrue, okay? So if I want to negate, I can use the word not. If they are not vertical angles, I can actually use the symbol. Like if I was using P and Q, I could put this symbol in front of it. So that means not P. If I say X is greater than 20, negating that would be X is less than or equal to 20. So I want the complete opposite of that. If I were saying that P equaled 5, well, the opposite, negating that, would be P does not equal 5. So those are some ways we can negate things in math. All right, guys, so that idea of negating is going to come into play in our next section. So I just want you to think about it. You're going to try some of the problems from 2.1, and that's really it. But let's see if you can remember what the word negate means for class tomorrow. Have a great day.